All right, so we're moving on now to application problems. Example 53 says the length of a bar X. So X in this question represents the length of a bar at temperature T degrees is given by the equation X is equal to X naught or X subscript 0 e to the alpha t. All right. Most times whenever you see something like X naught or X subscript 0 or X subscript O, most time that represents an initial value. At initial value, meaning that an initial value of the length of the bar, maybe the length of the bar at a time when the temperature was ambient temperature or something. Most of the time it represents some initial value. All right. So we're asked now to evaluate T. In other words, we need to find the temperature T when X is 2.62, X naught is 2.47, and alpha is 0.002. All right, so let's make T the subject of the formula. Now, for starters, I could divide both sides by X naught. And if I do that, I probably didn't have to, now that I think about it. Yeah, well, yeah, let it stay. So now I have X over X naught is equal to E to the alpha T. Now, if I take log to the base E of both sides, which is ln, so ln X over X naught is equal to alpha T ln E. So using my laws of logarithm, if you take the log to the base E of E to the alpha T, it's going to be alpha T log to the base E of E. All right, so that's using the laws of logarithm. Now, the log to the base E of E is 1. The log to the base E of E is 1. So therefore, I'm going to have alpha T is equal to ln X over X naught. Now, if I divide both sides by alpha, I'm going to get that T, which is the temperature, is equal to ln X over X naught divided by alpha. Now, if I put in all our values, I'm going to get T is equal to ln X, which is 2.62 over X naught, which is 2.47, divide by alpha, which is 0.002. So therefore, T would be equal to all right, so when you punch this in the calculator, somebody said you were going to get what, 29.5, and since it's T, it's degrees Celsius. All right, so example 54 says a liquid cools from its original temperature of 70 degrees to a temperature of what, 30 degrees Celsius in T minutes. Given that theta is equal to 70, e to the minus 0.02 t, find the value of I theta when t is 12. So theta is equal to 70, e to the minus 0.02 t. So when T is equal to 12. Theta would be 70. E to the minus 0.02 times 12. So you'd put that in the calculator and press equal. Anybody want to tell me what that answer is? Anybody? What's the answer?
55.064.
All right, so this is 55.1, and this is degrees Celsius. So in other words, the thing is cooling from 70 degrees, and in 12 minutes, the temperature fell from 70 degrees to 55.1 degrees Celsius. This is I. Now, I is asking us for it's asking us for the time when the temperature was at 40 degrees. All right, so let's make T the subject of the formula. T, I guess we didn't have to do it. I guess we could have started by putting in the values. So let's do this one like that. When theta is 40 degrees, so theta is 40, is equal to 70 e to the minus 0.02 t, and our objective is to find t. I can divide both sides by 70. And what I will end up with is e to the minus 0.02 t would be equal to 4/7. The zeros cancel. All right, take log to the base e of both sides. I'm going to get minus 0.02 t. ln e is equal to ln 4/7. ln e is equal to 1, so it's minus 0.02 t is equal to ln 4/7. Now, if I divide both sides by minus 0.02 minus 0.02, I'm going to get that t is, can somebody else put that in the calculator and tell me what to get? All right, so this would be ln 4/7 divided by minus 0.02 is going to be 28.0 minutes. In T's in minutes, and this is to 3 significant figure. So example 55 says the number of bacteria in a culture at time t was given by x is equal to alpha e to the 1/5 t. Find I, the number of bacteria present at time t is equal to 0. So the number of bacteria is given by this formula. X is equal to alpha e to the 1/5 t. Now at t is equal to 0, x would be equal to alpha e to the 1/5 times 0. So 1/5 times 0 is still 0, and e to the 0 would be 1. So x would be alpha e to the 0, which is just what? Alpha. So at time t is equal to 0, the amount of bacteria in the culture is alpha. So for I, the answer is alpha. Now II says the value of t when the colony has doubled its initial size. Now the initial size was alpha, So now for I'm going to say when X is equal to 2 alpha, that is when the culture doubles in its initial value. So we have what? 2 alpha is equal to alpha e to the 1/5 t. Now, if I divide both sides by alpha, I'm going to get e to the 1/5 t is equal to 2. If I take log to the base e of both sides, I'm going to get 1/5 t log to the base e of ln e is equal to ln 2. Now ln e is 1, so I'm going to have 1/5 t, which is the same as saying t over 5 is equal to ln 2 over 1, cross multiply to eliminate the fraction, and I'm going to get t is equal to 5 ln 2. I will just put that in my calculator and press equal. So can somebody tell me what they get when they put that in the calculator?
3.47.
Say that again.
3.47.
3.47. I'm not even sure if that is minutes or what. So it's 3.47. I'm not seeing the unit of time. So 3.47 units of time. Whatever the unit of time is.